Hi students, it's Dr. Marks, and I want to take a few minutes to talk about coding dummy variables and categorical variables. We've talked about this a little bit before, but it might be worth a review since we're going to be using both dummy variables and categorical variables as we proceed. Remember, often the data we get is in the form of qualitative information, and qualitative information is not quantitative. So we might be dealing with something related to gender. We might be using religion, year in college, like freshman, sophomore, junior, senior. And this information in this form is not understandable by a statistical program. It can't read male, female, Jewish, Catholic, right? So it has to be converted into binary information. Binary means that there are two states of the world. So when we're converting a variable to something binary with two states of the world, we call this a dummy variable. So we're going to be creating dummy variables. The simplest form is what I'm going to call a simple dummy variable. I don't know if that's really technically the term. We just call them dummy variables, but so that I can distinguish from other types. When I'm talking about a dummy variable like this, a simple dummy variable, there's just two states of the world. And creating this dummy variable is pretty easy. So as we've discussed before, it only takes one column to create a dummy variable for male or female. If I only have two options, male or female, then remember what we have to do. We have to assign one, the state equal to 1, and the other equal to 0. So maybe I decide to code male equals 1 and female equals 0. Of course, it could be the other way around. It doesn't really matter, but maybe depending on your particular investigation, you want males to be 1. So if you were trying to study something related to males, maybe it's just easier to give the male the 1. But your statistical package does not care which is coded which way. It just changes your interpretation. You might be flipping it in the other direction when we get to more sophisticated techniques. So remember, when we're coding dummy variables, which we're using for very specific purposes, we do not use two variables. We don't have male and female. We only need one. Slightly more sophisticated, but not difficult, is the idea of a categorical variable. Sometimes we know qualitative information has more than two groups. So we did a very easy male-female, but sometimes we have more than two options. So if I was thinking more modern times where we give more options, I might have more than one gender category. And instead of male, female being my option, maybe we want to add non-binary as a choice. And we're seeing that more and more now. If I was looking at religion, maybe I want to capture if people are Jewish, Catholic, Buddhist, Hindu. Again, these are what we call categorical variables, or you might see it called categorical dummies. Either way. It takes more than one variable to capture a categorical variable. In this case, we need n minus 1 categories. So whatever number of options I have, let's say it's 10, then I need 10 minus 1, 9 categories. So let's say that we develop a survey and we ask people to select the gender that applies to them. You have your choice of male, female, non-binary, but it's also often to say other or I do not wish to disclose. We see that often. So if these are the options I want to create in my survey, then I need 4 minus 1 equals 3 categories to be able to code it. Now, let's go back to our simple dummy. If I'm capturing male, female only, then we understand we only need one variable. And this can be done with one column as I've done here, because it's redundant to have a female column as well. Now, if you're trying to create charts or whatever, you might want to have two columns of data and count them or something. But we're moving in the direction of doing regression analysis. And in regression analysis, if we have male and female, and I accidentally put both of those in my model, I'm going to have this thing called perfect collinearity, and your statistical package will give you an error or it's going to drop one. It doesn't work. So if I need just male, female, this is sufficient. Do you agree that I already know who is female here, right? I can see person 3 and person 4 is female. How do I know that? Because male equals 1, and therefore anyone who got a 0 is female. So I have all I need. Now, if we are treating this as a categorical variable, because now we have multiple categories, for example, the 4 options that I gave you, it requires 3 variables. Remember, there's always one less column than category. Now, when we move on to talk about regression, this omitted category actually becomes our baseline for interpretation. So when we get to regression, not so important right this moment, but when we get to regression analysis, we have to think about which category do we want to drop out. And usually if it's something that is ordinal, we will take one of the ends. Here, it doesn't matter as much. Maybe non-binary or other would be a weird category to drop. Maybe I want it to be male, female. But if I'm talking about something ordinal, like, education, and I'm looking at degrees, they have an ordering to them. So maybe I drop high school only, or maybe I drop, another end. So you get the idea. So think about which one to drop, what makes sense. Usually we don't pick something in the middle if it's ordinal. So what category is the omitted category here? Well, hopefully you see that it is female. I don't need the female category because I have everything that I need. So let's add some numbers and look at respondent 001. So remember, this is a survey, so I'm probably not collecting people's names. So what do I know about survey respondent 001? Do we agree they are male? We have a 1 for male, 0 for non-binary, and 0 for other or do not wish to disclose. So it's very obvious that this individual identifies himself as male. Now, can we look at this data set and say, who is reporting as binary? Well, does everyone agree person 3, given the data I'm giving you here, person 3 is reporting themselves as non-binary, but they're the only one. Keep in mind, I only have a very small sample here, and in the real world, I'm collecting a very large sample, most likely, if I'm doing some kind of electronic survey. Who doesn't wish to disclose their gender identity? Well, it looks like respondent 7, right? Respondent 7 has a 0 for male, a 0 for non-binary, and a 1 for other or do not disclose, right? Who's female in this data set? So that's a little bit harder. How do I determine who is female in this data set? Well, do we agree? We're looking for the people that have 0, 0, 0. If I have 3 zeros, that means I'm not male, I'm not non-binary, and I'm not saying I don't want to disclose. So we can take from this that person 4, person 9, and person 11 are our females. Now, keep in mind, normally data sets are not this small, and this is just a representative example. If I'm doing a survey, it's probably a really huge data set, but maybe I get my results back and I see that I have very, very small numbers for some columns. Maybe I get very few non-binary and very few people saying other or not willing to disclose. Could I decide to collapse those 2 into one variable? I could. So if I wanted, I could take non-binary and the others do not disclose, collapse it into one variable, making this 3 categories, 2 being coded with female then as my omitted category. All right, so that is an option. You wouldn't know that going in necessarily until you see what your responses look like. Let's remember what purpose we're using this information for. We are coding qualitative variables in a manner needed for regression analysis, something that we're going to do towards the end of this class, and it's going to take up a couple weeks of our time. So we're not there yet. It's going to be later. And so what we're doing is the standard way of coding these variables. And to do that, we have to have an omitted category. And you're going to understand later, why do I need that omitted category? And does it matter which the omitted category is? Well, to some degree, yes, because it changes the way we interpret things, but it doesn't matter statistically. However, if you are trying to construct a pie chart or something, we're still in the descriptive statistics world and data visualization, it might be that you want to go back to the qualitative column. So if I'm trying to look at something, males and females, I can get all that from my dummy variable. I don't need to go back, but maybe if it's easier for you to think about, you go back to your qualitative columns and you can do something like a count if command, trying to figure out, well, how many males, how many females are in a data set if those are my only two options. So I'm not suggesting that you have to do everything off of your dummy variables. You certainly don't. I'm simply making sure that we know how to code them for future use. Now, please remember, variable names are important. We want variable names to reflect what it is that's being coded. So if you were to code something religion 1, religion 2, that's not very helpful because the person you're passing this off to might be saying, okay, now wait, what was religion 1 again? What's religion 2? It doesn't tell me what is equal to 1. So analysts don't want to have to rely on some big list of explanations. Now, I understand in the real world, sometimes with really big data sets, you have a whole page of notation with definitions. So sometimes, yeah, you need that kind of stuff when there are complexities, but why not make it easy when you can? And so when I'm working with my colleagues, if I name my variables appropriately, they don't have to keep going back to, well, what was this variable again? What's category 1? What's category 2? It just says it right there, and it makes it much more readable. So good variable names are important. Be sure that you're giving your variables names that indicate what is in the column. So gender would be not a very good variable name if I'm trying to code male equal 1, for example, right? Another thing I want to remind you of is that qualitative data can sometimes be hidden behind labels. And those labels might be numeric. It might seem quantitative, but it's not. Here's a good example. I was given some data with disability codes for schools, and those disability codes are numerical. But the thing is, the numbers have no meaning. For example, and I'm just making up these numbers because I don't remember what the numbers are. So if you're in a school system and you're going, wait, that's not the right number, I know, I'm making this up. But I got data that said, okay, code 50, and maybe that's a visual impairment, and code 30, that's hearing impairment. All right, are these quantitative simply because there is a number attached? No. I can make up numbers for anything, right? You're category 1, category 2, category 3, doesn't matter. They are still qualitative. This is still qualitative information, and you would still need to put in a dummy. So if a student has a visual impairment, then you would want to basically turn on that code, right? The 1 indicating this student has a visual impairment because it is qualitative. We still have to create dummy variables here. So gang, let me know if you have any questions. I hope that gives you a good review and helps you remember some things as you're working with data sets. All right, have a fantastic day, everyone, and thanks for listening.